So that's something that, like, that ordered pair is attached to a pi over 3 angle. The only difference is the reason you graph it is so that you can see the location, because once you know it's on the negative x-axis, or in the second quadrant, we need to make the x value negative. So after you have the ordered pair, the directions wanted you to find the sine, cosine, and tangent. 2 of those you can do without any work whatsoever. How can I find the sine and cosine when we have an ordered pair? Reese.
You said the ordered pairs, the first number is the cosine, and then the second one's the sine.
Right. So in your ordered pair, the x value is the cosine, and the y value is the sine. And that's because if I think about it as being a triangle, because that's really what's there, and that's how we kind of manipulated those triangles yesterday, the cosine is the adjacent over hypotenuse. The adjacent side is always x. The hypotenuse side is always y. I'm sorry, the opposite side is always y. So my adjacent over hypotenuse is going to be the x value if the hypotenuse is 1, because anything divided by 1 is just x. The sine is the opposite over hypotenuse, while the opposite is the y value, that vertical distance that I would travel up. So that's why the sine value is 1. So that means my cosine in this problem is negative 1/2, and the sine of my value is square root of 3 over 2. And I can do that without any work besides having a little diagram drawn. But how do you find the tangent? Okay, you don't have it yet, Reese. Sorry. How would you find the tangent? So we know the ordered pair is cosine and sine. Right? And how do you get the tangent?
You take the square root of 3 and divide it by -1.
Why?
Because the square root of 3 is the opposite side, and then 1 is the adjacent side.
Why?
Because that's how sine and cosine.
Kind of. But the whole thing represents the sine. The whole thing represents the cosine.
You would take the sine over the cosine.
So the tangent is equal to sine over cosine. And that, I know we haven't actually discussed, but that would have been the second to last term at the bottom of that first page. So tangent is sine divided by cosine. Well, my sine value is the square root of 3 over 2, and my cosine value is negative 1/2. And when you're dividing, if the denominators are the same, what happens to them? They cancel. And then I'm left with negative square root of 3, because the square root of 3 divided by negative 1 is negative square root of 3. Questions? So today we are going to work with finding the sine, tangent, cosine, but we're also going to learn about 3 new trig functions that you would have never seen before, because there are actually 6. So we're going to talk about all 6 trig functions and how we can find values for them. So this section right now is just kind of getting us familiar with this chart called the unit circle, and how this chart can give us the values for 6 trig functions, not just the cosine and sine values. And then as we work through the entire chapter, you'll see how the chart can kind of be built on, and we'll start applying things to the chart. We have to be able to use it and understand it first before we really can apply it. Questions? Like questions from yesterday on the unit circle, how we created the chart. So start thinking about like the angle, whatever's in the denominator, we need to start associating that ordered pair with it. So if it's pi over 4, any pi over 4 is the square root of 2 over 2, square root of 2 over 2. So like these 3 angles, we need to kind of start associating the ordered pair that goes with them. Yeah?
Do you have like blank ones?
I do have blank ones. I would need to make copies of them, but I can give you blank ones tomorrow if you can stop by sometime today and I can make copies later. To like practice writing, working through them, yeah, I can do that. You know what? It would be on Google Classroom as well. You can pull up a blank one. I can post it there too. Other questions? So in your packet, I believe if you just look at the next page,
Yes.
what page is that? 8, 9,
13.
13. Okay, 13.
Yeah.
So at the top of page 13, you see there are 6 functions that are listed. And we're going to define these 6 functions. I'm going to draw a little diagram so that we have that as a reference. But it says let t be a real number. And that's how the problem, like in the book, you were given an angle, a value for t in radians. And it says xy is a point on the unit circle. So draw yourself a circle. Make mine a little better. That's a little better. I'm going to draw in the xy axis because the unit circle is really on top of our xy axis that we've worked with through all of algebra. So it says we have a t value that's a real number. That number creates our angle. And then we have a point on the edge of the unit circle corresponding with that angle t. And I know to get any point, really I have to travel over a distance x and up a distance y to get to that point. And the hypotenuse of any unit circle is 1. Or the radius of any unit circle is 1. So the radius and the hypotenuse are the same value. So knowing what we talked about yesterday, the sine is opposite over hypotenuse, or the sine is just equal to y, because the hypotenuse is 1. The cosine is adjacent over hypotenuse. Well, if I look at my little diagram over here, I created a triangle. My adjacent side is x, the hypotenuse is 1, so the cosine would just be x. So again, I'm using the fact opposite over hypotenuse. That's still that SOHCAHTOA is kind of embedded in this, and adjacent over hypotenuse. So what 2 sides would the tangent be? This is the first question on yesterday's quiz. What 2 sides of the tangent? Opposite over adjacent. So if you look at your triangle, Colin, what side represents the opposite over the adjacent? Y over x. So when we calculate the tangent, we're really taking the y value and dividing it by x. Or I'm taking the sine and dividing it by cosine. So the ordered pair that we get at this point, if I want to find the tangent, I can take the y and divide it by x. Because my y is opposite and the x is the adjacent. And that's how I find the tangent. It's opposite over adjacent. Except we have a y and an x to represent those. So the other 3 functions that are right next to them are their partner functions, their buddy functions. They're reciprocals of each other. Does anybody know what CSC stands for? Gabby?
Would it be hypotenuse over opposite?
It is the hypotenuse over the opposite. Why would that be, Gabby?
Because you said they were the reciprocals.
Perfect. So they're reciprocals. So the sine is a reciprocal with the cosecant. So reciprocal means whatever I have for sine, if I flip it, that's what I have for the cosecant. So CSC represents the cosecant function. So Gabby, the hypotenuse over the opposite would be
1 over y.
excellent, 1 over y. So the cosecant can be found by using the sine, which is y, so that means I take 1 over y. So they are reciprocal functions. The sine function and the cosecant function are reciprocal functions. So my second function is a reciprocal with cosine. They're across from each other because Those are the partner relationships. And this is called the secant. And I know you're thinking, gee, it would make more sense if the secant and cosecant went together. But they aren't the original three functions. So sine was an original function, cosine is an original function, and the tangent is the original function. Anytime you pair them up, the sine and the cosecant, you have to have an S function with a C function. The cosine is with the secant. So the C function is with the S function. What would the cosine and the secant, what would the secant be? Oh, yeah, that's going to be 1 over x, because again, it's the reciprocal of the cosine. So it would be the hypotenuse over the adjacent. The last one is the pair that makes sense, because I have the tangent and, what do you think COT stands for? Cotangent. So the tangent and the cotangent are reciprocals, therefore, Colin, the cotangent would be, if the tangent is y over x, the cotangent is x over y. So I can define 6 trigonometric functions, and there are only 6. There are not any more to learn. Just with 2 letters, x and y. 1 ordered pair, 1 point on the graph, enables us to find or calculate all 6 trig functions. So that's what we're going to look at today. And then you're going to complete a really big chart, which I'll show you where that is in a little bit, to be able to find the sine, the cosine, the tangent, and their buddy reciprocal functions for any angle on the unit circle. So down below there are some examples, and we're going to start out with the angle of 0. So the first thing we're going to do is draw the graph. Always start with the sketch. The sketch enables us to kind of see where does it lie, does it have a positive x, a negative x, and then we're going to list the point on the circle as well. So make yourself a little sketch. You'll get good at drawing circles. Yeah. So Brenton, where is the angle 0? Yeah, right on 360. Right on the positive x-axis. And then it says the point on the unit circle. So if that's our angle, Brenton, what is the point on the edge of that unit circle represented by that angle? It is 1, 0. Because we're moving over the distance of 1, the unit circle has a radius of 1. We're not moving up or down. So that would be my ordered pair. So now we're going to evaluate the 6 trig functions using that ordered pair and the definitions above. So starting with the sine, and you can either place the sine of t or the sine of theta there, but you have to have something because it's the sine of the angle you're working with. So the sine of t, cosine t, tangent t, and then right next to them, they're buddy functions, they're partner functions. So the cosecant, the secant, and then the cotangent. So Brenton, using the definition above, the sine of t is equal to? Here's my ordered pair. Which letter of the ordered pair is sine? It's 0, yeah. So the sine is the y, the cosine is the x. So the sine of t is 0. Brenton, the cosine of t is 1. And then the tangent of t, why is it 0? Excellent, yeah. So it's y over x, or as he said, 0 divided by 1 is 0. So then when you go right next to it, the reciprocal functions mean I take the answer I have. How do you do a reciprocal, Brenton?
It would be 1 over 0.
What is 1 over 0? Undefined. So that means the cosecant doesn't exist at the angle 0. Brenton, the secant is? Which is just 1. And then the cotangent? And that's undefined. So we don't have a cosecant or a cotangent value for the angle of 0. functions for the one angle, angle 0. Every angle 0 has those 6 values. The values do not change. So every angle of 0 will always have those 6 values for the functions. So if you look at letter B, we have pi over 6. So again, start off by graphing yourself, draw yourself a little circle. Pi over 6 is my smallest of the angles between pi over 6, pi over 4, pi over 3. So that's the first angle, because it's a 6 at the top of the circle. So we need an ordered pair associated with pi over 6. What's the point on the circle that goes along with pi over 6? If you need to, you can flip backwards. It's on the front of the packet. Emma. So square root of 3 over 2 and 1/2. Every pi over 6 has that same ordered pair, the square root of 3 over 2 and 1/2. So doing what we did before, we're going to see if we can find those 6 functions. And then we'll try and get the reciprocal functions as well. So Emma, the sine of pi over 6 is 1/2 because the sine is the y. The cosine would be perfect. And then to find the tangent, you're now taking those two values and we're taking y and dividing it by x. So we're going to take 1/2 and divide it by the square root of 3 over 2.
Square root of 3 over 3.
So she said square root of 3 over 3. So my 2's cancel, leaving us with 1 divided by the square root of 3. And when you rationalize that, we end up with, should move this guy over a little more, the square root of 3 over 3. So the 2's cancel, the denominators are the same. We end up with 1 over the square root of 3, which is really the square root of 3 over 3. So then when I go to do the reciprocals, Reese, what would the reciprocal of the sine be to get the cosecant? Yeah, what is 1 over 1/2? What's another way of finding the reciprocal instead of saying 1 over 1/2? What's a quick way that I can find the reciprocal? So if I say 1 over 1/2, what is another way of really finding the reciprocal instead of placing it underneath number 1? Carrie?
Just flip.
Yeah, just flip it. So you flip it to find the reciprocal. So if I have 1/2, the reciprocal of 1/2 is 1 over 1/2. Or if I flip that fraction, I have the reciprocal. It's 2. So you flip to find the recip. So take that fraction and flip it. Yeah, haha.
I like that.
You like that. Flip to find the recip.
Imagine.
So if I use that same thought process, Reese, the cosine is the square root of 3 over 2. If I flip it, the secant would be,
2 over the square root.
and then what do you have to do to simplify that?
Multiply it by the square root.
Multiply it by the square root of 3. So now I have 2 square root of 3 on the top, and the bottom is just the whole number of 3. So the last one is the cotangent. I would go back to the original fractions and flip that. So I had 1/2 divided by the square root of 3 over 2. If I flip that whole fraction, I end up with the square root of 3 over 2 divided by 1/2. So if my denominators are the same, they cancel. What's the cotangent equal to? The square root of 3. Questions? So why don't you try 3 pi over 2. So same process, just giving you a different angle to work with. So this is getting you kind of to understand the location of the angle and to try and start thinking about those points associated with that angle. Nick, do you know where 3 pi over 2 is?
3 pi over 2 is that the 270?
That is the 270. So if I have 2 pieces of the pie on the top and going to the bottom and counting to my 3rd piece of the pie, that angle is at the 270 mark. Nick, what's the point at 270?
0,
Yeah. Remember, you're down now. That's why the y is negative. So 0 and negative 1. And now I have my ordered pairs so that we can get those 6 trig functions. So Nick, the sine is the cosine,
0,
and then the tangent.
that would be 0.
Yeah, so it's y divided by x, negative 1 divided by 0 is undefined. Nick, the cosecant would be,
That would be 0 over -1. Right?
so I already have a negative 1.
Yeah,
So it's going to be negative 1 over,
over 0, which is
what's this
Yeah.
number? What's this number over right now?
1. So
Yeah.
it's still -1.
Yeah, there you go.
Sorry, I'm
So if it's all right. If I flip that, I end up with 1 over negative 1, which is negative 1.
Yeah.
Nick, the secant is,
That's 0 over 0, which is 0. Negative or 1. I'm lost.
it's all right. I won't pick on you anymore. So the
Sorry.
cosine is 0 over 1. So the secant is 1 over 0. That's undefined. And then the tangent was negative 1 over 0. So the cotangent is 0 over negative 1, which is 0. Remember, flip to find the recip. If you need to make it into a fraction to flip that, you can do that. I think there's a couple more down there, but we're not going to do all of them. Let's do letter D, and then I want to kind of show you how to think about the chart. So letter D says 3 pi over 4. We haven't done a pi over 4 angle yet. So remember, the 4 means there are 4 pieces of pie on the top, 4 pieces of pie on the bottom. And if I count to my 3rd piece of the pie, I have 3 pi over 4. So pi over 4 is the angle. That's the family. But it's on the negative x-axis. So I know my x has to be negative. Josh, what is the ordered pair that goes along with 3 pi over 4?
Negative square root of 2 over 2, positive square root.
Right. Which would be the same for positive pi over 4. It would still be square root of 2, square root over 2, square root of 2 over 2. It's just the x value is negative. So, Josh, the sign is
Square root 2 over 2,
positive or negative?
positive.
Yeah, because it's the y. The cosine is,
Negative. Can you say root 2?
yeah, you could say root 2. That's awesome. So then you're skipping that whole square root. You don't have to say 2 words, yeah. And then the tangent. Josh, how would you find tangent?
You put root 2 over 2 over negative root 2 over 2. You can take out the 2's. We have root 2 over negative root 2. That's negative.
That's negative 1. Nice job. So the 2's, the denominators cancel. And then as he said, we have the root 2 over negative root 2, which is negative 1. So when we go to do the other pair, remember, flip to find the recip. So if I have root 2 over 2, you're flipping that. The 2 is now on the top. Colin, if we rationalize this, multiplying the top by the square root of 2 and the bottom by the square root of 2, what's that become?
You would get 2 square root 2 over 2, which just equals root 2.
Yeah, nice. So those 2's cancel, and you just have the square root of 2. So flip to find the recip, and then rationalize it. If you look at the cosine, the secant goes with the cosine. So again, flip it. So now I have 2 over negative square root of 2. What does that become, Colin, as you're taking your turn? I'm sorry.
It would become 2 over negative 2 root 2 over 2.
So if I multiply square root of 2, square root of 2, 2 square root of 2 over negative 2 is negative square root of 2. These should be the same because I'm starting with the same ordered pair. It's just this value is negative. But if my ordered pair is the same, I'm having the same value for x and y, so they should be the same value as well. And then the last one, if the tangent is negative 1, what's the reciprocal of negative 1? Here? Negative 1. So negative 1 over 1 is still negative 1. Questions? So in your packet, you're going to have to flip a couple pages. I don't like where I put the chart. So what page is it on? 19. So flip to page 19.
Hello.
This is our trig chart, which will be very handy once you have it complete. Because now this is a reference that you have for any function in any angle, the 32 angles that are on the unit circle. Above each one of the functions, we're going to label them with their definition. So the sine is equal to which letter? Opposite over adjacent or hypotenuse, or it's equal to y. So now we're thinking the sine is the y. From now on, it's y. Instead of opposite over hypotenuse, it's just y. The cosine is x. Yes, it is the adjacent over the hypotenuse, but the adjacent is now the x of the triangle. And the tangent would be y over x. So those are my 3 original functions. The ones next to it, if I flip that, the cotangent is x over y. Remember, tangent and cotangent go together. The secant goes with the cosine. So it's 1 over x. The cosecant goes with the sine. So that's 1 over y. Those are the 6 trig functions and their definitions. So the definition is just pretty much what it's equal to. So I want you to go through and divide up our quadrants. So after 90 degrees, put a little line and remind yourself that this is quadrant 1. And in quadrant 1, we should have a positive x and a positive y. I'm going to also place a line after 180 degrees and put a quadrant 2. In quadrant 2, I should have a negative x and a positive y. Going down to 270. Anything in between here is quadrant 3. What happens with quadrant 3 in my ordered pair? Both negative. And then the remaining angles are quadrant 4,